Hi, I was going to show you how to do one of these problems for 9.1 in your calculator. So let's do this problem. In baseball, is there a linear correlation between batting average and home run percentage? Let X represent the batting average of the professional ball players, and let Y represent the player's home run percentage, number of home runs per 100 times at bat. A simple random sample of 7 professional baseball players is given with the following information. Okay, so here's X and here's Y. So here we can see I've worked, the student has put in the dots, which is great. And again, if you need help graphing, there's some information there to help you. Do it by the points. It makes it easier. And all you're doing is remember, for every X, there is a corresponding Y. Because remember, with linear regression, we're looking at the X's and Y's together to see what kind of relationship there is. All right, so then the next thing that it wants us to do, it wants us to verify the points that, summation of X squared, summation of Y, and summation of Y squared, and then summation of X and Y. So let me show you how to do that really easy on your calculator. Okay. Your calculator might be a little different than my calculator, but there's easy ways to do this. So I do stats and I hit enter. So I have my X's in L1 and have my Y's in L2. So to find the summation of X and the summation of X squared, I'm going to do stats. I'm going to go to calc. I'm going to do one var stats. And for this one, I don't know if you can see it. It's this tiny L1 on my TI-83. On the 84s, you can actually put in which column it is. So I'm going to do second and 1 to call for it, and then I'm going to hit enter. So if you look right here, the summation of X is 1.951, which goes right here. And the summation of X squared is 0.500, and that goes right here. Okay, I can do the same for the Y's. So if I go to stat, go to calc, and hit enter again, and now I'm going to do second 2, because it tells me L2. Again, for the 84, you can physically put in that it's L2. So I hit enter, and look again. So now the summation of Y, it still says X because the calculator doesn't change that, but look at the values have changed. The summation of Y is 29.7. The summation of Y squared is 146.79, which is the same. To get the summation of X and Y, I'm going to take the values I had before. I had 1. Oh, excuse me. So you're going to take that. What you're going to have to do is do that by hand. So what you can do is take the sum of all your X's and then the sum of all your Y's and multiply those together. It's pretty easy to do. So just make sure you do that. Okay. So let me keep going here because the calculator doesn't do that for you. I don't think it does. So I would just be careful of that. Okay. So the next one is how you get that R. So here's the easy way to do that. And I know the answer is showing, but let me show you how to do it. Go to stats, go over to test, and then you're going to go all the way down. And you're going to see I use the Linreg T-Test. There are other ways to do that that might be easier. I do this one. I think if you keep going down, there's other ones. But for me, this is the easiest one, and I'll show you why. Okay, there's a ton of them, but I use Linreg T-Test. I hit enter. L1 is my X list. Y list is in L2. Frequency is 1. I always do that because it's saying there's a 1-to-1 relationship. I do not equal 0. And then I hit calc. Okay. Y equals A plus BX. Remember, that's the same as Y equals MX plus B. This is just flipped around a little bit. So I have a p-value. I have degrees of freedom. Don't worry about that. I have an A, which is A in this case is the y-intercept and B is the slope, and it gives it to me. So if I keep going down, look, there's my R value, 0.9549, and if I round up, it's 0.955. And that's how you do it. And the good thing, though, again, is if you need the line of best fit, here it is. Again, y-intercept is negative 10.96. The slope itself is 54.56 if I round up. Hope this helps.